Perfect. So looks like we have a critical mass here. We'll go ahead and get started. I want to thank everyone, first off, for joining us today and being a part of this MLOps.community talk. We have a very special guest, and Phil Winder is here. He is going to talk to us about the hierarchy of needs within MLOps. And we thought we would just have a conversation around how the hierarchy of needs looks in his eyes and how he sees it. I'm going to be starting off asking him a few questions. And then once we get into the flow of things, if anyone has any questions, feel free to jump in. You can write them in the chat, or you can also put them, just unmute yourself and go ahead and start speaking. The one thing that I wanted to mention before we go ahead and kick this off is that we have a Slack group, and we would love for you to jump in the Slack group if you're not in that already, where we talk about everything MLOps. And yeah, it's in the chat right now if you want to go ahead and sign up there. And that's about it. If I forgot anything, I'm sure someone will remind me later. But let's go ahead and get started. Phil, I guess my first question for you is, can you start us off in the beginning? Where did your love for technology come from? How did you get into that? And a little background info for us.
Yeah, I'll try and be very quick then. And I wouldn't call it love, I'd call it love-hate as well, because there's a lot of hate in there as well as love. But no, I started off in electronics, actually. I find it really interesting when you speak to engineers, their backgrounds are often not computer science and not software engineering. They come from physics backgrounds or math backgrounds. Mine was electronics, and yeah, about a decade ago, there was a big push towards writing software in chips, microprocessors. And over time, it became clear to me that software was eating the electronics world. And yeah, I mean, these days, really, electronics is all about just buying a mini computer, stuffing it inside something small, and then writing software for it. There's actually not as much electronics going on as there was. So I made the jump eventually to software engineering via signal processing, because I was doing a lot of DSP work in chips, and I jumped across to software through signal processing, which is where I really started working with data, and that was kind of before data science existed, or even sort of machine learning. Really, it wasn't really a term that was used that often. And slowly over time, I learned how to do software. Followed all the data stuff as well, and I kind of ended up here where it's half software, half data science, building products for people. So yeah, that's the history.
Perfect. Thank you for that. And so, as people saw on the slide when they were coming in, you're the CEO of Winder Research. What do you do there? What does that entail? Can you give us a bit of info on that?
Sure, yeah. So I run a data science consultancy based in the UK, but we work throughout Europe. We work primarily on two types of projects at the moment, but that is very market driven. One is on raw applications. So there's quite a few companies which need help developing their machine learning / data science applications. So we help them build that, productionize it, and ship it. And the other side of the business is working with larger companies and enterprises where they know that data science and machine learning is becoming a bigger and bigger part of their business. But all of the tooling and the processes are not mature. And so they're reliant on using old processes built for software engineering that don't really fit data science. So we go in there and help them improve processes, help develop new data science platforms if that's what they need, or basically help them go from idea to production in a shorter time as possible.
Cool. Yeah, that sounds real interesting. And my question with the big and the small companies, have you noticed the difference between those two on how agile they are at putting models into production? Are the big companies a bit more slow to act when it comes to building out data science teams and putting models out there?
Yeah, certainly, but it's not quite as clear cut as that, because it's fundamentally driven by the resources that each company has and the resources that they can afford to put into that effort. For smaller companies, they don't have the resources they don't have an operations team, for example. So they're really focused on building a fully automated end-to-end system. Whereas a lot of these big companies still have very large operations departments, and they're still quite reliant on them. So they actually don't mind building a more traditional operations heavy kind of workload. And that has knock-on effects as well. So that means that the small company is tending to use more managed and hosted services, whereas larger companies are tending to build a little bit more than they buy, because basically they can afford to build something that is more specific to their requirements.
Which of those is being successful?
Say that again, sorry?
Which of those routes are being successful in those contexts?
Well, I mean, both are successful, but they both have challenges. So, like, if you're a small company trying to develop a single thing, it'll probably work well to begin with, but eventually you get to the point where your managed service doesn't do what you need it to do, and then it starts to become a bit of a Frankenstein as you start patching stuff on. Whereas the larger company, you get the opposite problem. You've got so much flexibility, it becomes very hard to focus, and so you end up building a lot of stuff, but actually delivering very little. That's a very easy trap to get yourself into.
Yeah, a lot of that happens.
Yeah, I think there's two great points there with the Frankenstein piecing together lots of different parts. And then I'm wondering about, with these big companies, do you see a lot of tools being used together where they're taking maybe 3 or 4 of the same tools that do ultimately, they don't do the same thing, but they have a lot of overlap?
Yes. And quite often you get a lot of opinions in the larger companies from engineers as well. And engineers are great for opinions, where they think that one particular product is better than another and then maybe it's right for a particular use case. It could be better, and so you do end up with competing approaches. And when two teams collide, one's using one and one using another, that's kind of okay to a point. But a big part of the push for a more organized data science strategy from within a big business is the idea of unification. It's trying to unify on a single set of tools, ideally a single set of tools, because it then becomes much easier to manage and operate.
Yeah, completely. And so can you give us a few case studies of different tools that you've implemented and how you've gone about that?
Yeah, so I could try. So every technology under the planet is under makes us sign a massive NDA before we start any work. So I can't talk specifics about specific companies and stuff, but I can talk in general. So yeah, and are you interested in a specific part of the stack when you ask that question, or is it?
Well, really, what I've been hearing a lot come up recently is monitoring. So
Okay.
if you have any use cases about how you built out something with monitoring pieces, I'd love to hear about that.
Yeah, so most of the work we do when we do build a more custom solution is usually based upon Kubernetes. So even the larger companies now have got there's a lot of traction for Kubernetes inside those companies, and so newer software is being built upon Kubernetes. So all of the tooling, the monitoring tooling that is currently being used for Kubernetes kind of finds itself landing in the data science scene as well. So there's lots of Prometheus, lots of Grafana, maybe even using sort of the Elastic Stack to do some of the work there, especially for the logging. And then Yeah, I mean, there are other proprietary companies as well, and I don't want to really name any but there are proprietary services out there that you can also hook into Kubernetes, which work really well. I think it's a very important part of the problem, and in fact, I think the valuations and the amount of money that some companies have got for just doing monitoring kind of highlights the fact that everybody needs monitoring. Yeah, I think in terms of gaps, at the moment we're kind of retrofitting software engineering tools to do the monitoring. So you're very reliant on basic statistics and also working with very low resolution monitoring data, you know, kind of like single summary statistic type data to monitor your applications. And sometimes that's just not good enough. You know, quite often we're interested in distributions and representing distributions and comparing distributions and things like that. And if you do want anything like that, it ends up being a lot of custom code to be able to implement that. So yeah, I think there's a gap in the market for a slightly more focused, a monitoring solution that's more focused towards data science and ML.
Perfect. I see Eduardo had a question here in the chat. Do you want to go ahead and ask that, Eduardo?
Hey, hello. Yes, I can. So my question is, and by the way, I'm also coming from electronics. So
Cool.
And okay, so my question is, what are the main friction points between data scientists and software engineer? Because as operations, as a operations engineer with background, I see this fight again between software engineers and operations. So what's new?
Yeah, well, nothing's new. It's the same old story. Totally agree. So just to paint the picture, you know, 10 years ago, maybe not even 10 years, maybe less than that, there was a big divide between operations staff and developers. Developers would develop software. I mean, you've all heard this before, right? It's the whole reason why DevOps became a thing, was to try and attempt to smash down that wall between the developers and the operations teams. And that has worked somewhat. I'd say in larger companies, there are still very big operations teams. So they still exist and they're still there, primarily because there's also a lot of old software still running. So they need to keep running that software. So yeah. And so when I sort of started doing data science ML more full time, which is kind of about 2010, the same thing was emerging with ML. I would write algorithms, I would develop, you know, data science solutions, and then I would hand it off to a software engineer and expect the software engineer to implement that properly, because data scientists can't write proper software. And then that would then go off to the operations. And so you had these, you know, multiple jumps, and it was a daily exercise of complaining about the other person. So the software engineer would complain to the data scientist saying, you know, I don't understand this. What's going on here? It's crazy. It's too complicated. And the data scientist is going to the software engineer. It's like, it's not complicated. It's dead easy. How can you not understand it? So I fully agree with the push of DevOps up into data science as well. And I guess that's kind of falls under the banner of MLOps. Or data DevOps, or whatever you want to call it, but basically trying to bring the data scientists into the software team, into the operations team, and so all together as a team, they can actually they can be responsible for, and they can deliver good ML solutions. The downside is that in many sort of roles, that scope falls towards a single person. It's becoming more and more expected that a single person would be skilled at doing all of these things. And so that makes the stack, the full stack is becoming fuller. Like the word full stack is pretty funny because it implies that there's nothing else to add. But in fact, there's stuff being added all the time. So we're going, you know, uber full now if you're adding data science on the top of that. And there's obviously a limit to that. There's only so much that someone can learn, and yeah, so that's an organizational challenge.
Yeah, the full stack is now overflowing stack.
Yeah, right.
I read your blog article about that. I thought that was a great point about how people are expected to know such a wide variety, and if you call yourself a full stack, now you have to go from here to here, and it's no longer just this.
Yep.
But pivoting a bit more into MLOps and how you see it in the hierarchy of needs. We had Luke on here 2 weeks ago, and I think he's in here right now. He's in the chat somewhere. I saw him earlier, but he was talking about this MLOps Manifesto, and he says that everything needs to be reproducible, accountable, collaborative, and continuous. And so we had a good talk prior to this, but I wanted to get you to reiterate that on your take on that, how you feel about it, what you think, and what your general thoughts are.
Yeah. Okay, great. So when I saw that too, and the first thing that I thought when I saw that was like, yes, great, they're all best practices, but what about everything else? You know, that was my immediate thought. There's a lot more to it, and especially from my experience in my day-to-day role, like the vast majority of my work is what I would consider software engineering. I wouldn't even really consider it like ML or data science, because it's just, yeah, software engineering. And that I think that all needs to be in place before you start considering these higher level best practices, these data science best practices, because, like, you know, if things are being trained continuously, like, it doesn't really make any sense to do that if you don't even have version control in your software. Like, believe it or not, still some companies don't have version control. They're still making that transition. You know, there's a lot of old software out there that don't have anything like this. So there's kind of little point focusing on this when you've got the basic needs that need to be met before you can do that. So that kind of started me, that sent me down a path thinking, well, okay, if there is something underneath this, then what is that? I think, yeah, in fact, if I just share my screen, I've just got a couple of slides here to kind of talk through this. I think this is probably a good opportunity, if that's all right. All right, so let me just present this. All right, so hopefully everyone can see that. So I started looking at that, and there's more and more best practices being developed every day, and they're all sort of good best practices. It becomes quite difficult to actually abstract and categorize those best practices a little bit, because they tend to be quite sort of super focused on a single task. But still, many best practices emerging every day as people gain more experience with running data science and ML projects in production. But I propose that these best practices kind of imply a whole range of basic needs. And so that got me thinking about needs, about analogies, and how this relates to software and data science in general. What are those needs? And was there any sort of prior work on defining what those needs are? And the first one that you come across is something called Maslow's Hierarchy of Needs. And so this is a chap, Abraham Maslow, who in the 40s and 50s developed a psychological theory suggesting that in order to attain cultural enlightenment, you need to have a set of base, you need a set of, there is a set of needs that have to be in place before you can graduate to the next level. And so he came up with this hierarchy of needs here, where on the lowest level you have, like, you know, fundamentally, like, basic human needs. If you didn't have these, then you wouldn't be alive. And then on the next level, we've got a safety layer where you need the security, and you need to be able to live your life. Then in the layer up, we're getting a little bit more sort of psychological, and you need to belong, and you need to have friendships and have relationships and things like that. Once you have that, then you can start building confidence and self-esteem. And finally, you get to these sort of high level cultural concepts at the top level, morality and creativity. And he was arguing that if you didn't provide for the things below, then you're never going to get the things above. So there's no point trying to make a society moral or creative if they are being threatened, if there's a war going on at the time. Like since then, subsequently more recent research has kind of found that it's not strictly this or that. So for example, you can be in a war-torn country and build relationships with people. So it is still possible to kind of shortcut. But I think in general, this is kind of accepted as a rough rule of thumb in psychology. If you have problems lower down, then you have problems above. Does that make sense?
Yeah, that's perfect. That's great. So as far as MLOps hierarchy of needs, what do you think is the base, and how does it go up?
Exactly. And that's the tricky question. It's like, so I started thinking, what is really required? What is required to do a project, to build an ML product? What do you really need? So I kind of started thinking about that, and this is just a bit of a first draft. But I tried to draw a triangle, and no matter which way I spun it, I couldn't really fit it into a triangle, because there was sort of two dimensions. I maybe could have done it if it was a pyramid, actually, but I thought that a pyramid might have been beyond my graphics ability. So I went with a table instead. As a data scientist, we love tables. And so I kind of had these two axes where I was trying to think of like, well, you can't really do data science without software engineering, and you can't really do software engineering without having some kind of framework in place. So, all right, that's kind of one dimension. And then there was another dimension where I kind of saw that some things are required and some things are not. Like you don't need like full automation to be able to build a product. Like you don't even really need provenance in an ML pipeline to build a product. You really can just get away with, deploying a model, and there you go. You can just about make it work. But there was this level of, there was this kind of idea of, but it is valuable. It becomes valuable over time. When you have more and more in production, you have more to manage. Things start going wrong and you need to go backwards and forwards in time, then that becomes really valuable. And so I came up with like these two axes. We've got on the x-axis, we've got the kind of the value of having a particular concept in place, and on the y-axis in the rows there, we've got kind of three sort of key parts of the problem as I see it. So from top to bottom, we've got data or data related concepts, data science, ML all fit in there. Underneath that, we've got software engineering. And then finally at the bottom, I couldn't really come up with a decent name for this, but I eventually went with governance. And this is the idea that in order to deliver a product, you need some structures in place to be able to do that. Like even if we just ignore the data part for a second, and this was just a pure software project, if you were trying to develop and deploy a software project, then you wouldn't really be able to do that without having the backing of a team or a company or a process to be able to develop that. So I kind of thought that there was this like process layer that was required at the bottom. Yeah, and then going across on the x-axis, I tried to sort of segment the best practices into sort of three values. One where it's just absolutely required. If you don't have this, then you can't do anything. You don't have a product. You could kind of think of that as like MVP type stage. To be viable, it kind of has to, you have to have all of those things. Then there's a second layer where things start to add value, and they only add value when things start to scale. And then finally, there's like this golden optimal region. And I think the thing I'd like to point out in this is that in all three boxes, I've put the word automation, and that's kind of the holy grail of of everything that we do. And that is to automate everything so that we don't have to do it anymore. And that's a good thing or a bad thing, depending on what you how you look at it. But if you can automate all of the processes and all of the governance, then that will make everybody's life a lot easier. If you can automate all of the software, you don't need to do any software related tasks anymore. That's great. And finally, if you're automating the models and the things relating to the data itself, then, you know, well, we're out of a job, I guess. But I don't think that'll happen very, very quickly. But that's kind of the golden state. So does that all make sense? Any questions based upon that? And maybe we can talk about the sort of individual topics a little bit more in a minute. Completely.
Yeah, that's great. And if anyone has a question, feel free to cut me off, because I'm doing a lot of talking. But I find it really interesting that you put governance in there, because last week we just had a talk with Charles, and I think he's in here in the chat also. And so I'm wondering why you've chosen to put governance there at the bottom.
Yeah, well, I mean, originally it came back to this hierarchy of needs. It's like, well, okay, if I've got, so starting from the top, if I'm trying to do a data science project, what do I really need underneath that? Well, we need software. So most of data science is just software engineering. So I'm going to put the software engineering underneath there. Okay, what do I need to do software? I mean, it's a pretty sort of philosophical question, but what do I really need in order to build software? And then I kind of started thinking that, well, we need processes and structures in place to be able to do that. Like and that applies from anywhere. If you go and work on an open source project, the bigger that open source project is, the more processes you will find embedded within that project. And they're there because they're required to orchestrate the distributed work. If you go to a big company, then obviously there's all sorts of processes in there, and most of them are horrible. But even if you go to a smaller company, you know, there's always a boss, there's always a customer, there's always you know, probably fellow engineers working on a project, and so there's some level of process that is needed to do that in the first place. So that was basically the reason for it. I thought that is the base layer. That is this physiological safety layer at the bottom here. And I guess what that means is that software engineering is love and belonging, and self-actualization and esteem is maybe data, if you want to make some direct analogies.
Perfect. So as you go back to that other slide, mm-hmm. and you look at it and you see products, I imagine you're working with a lot of tools and products each day. How do products fit into this?
Yeah, good question. But I also thought of a very interesting question, because there's quite a lot of there's a lot of sex related stuff in here. So I don't know if this is software, and where does software fit into sexual intimacy? I'm not sure. There's probably companies out there that are focusing on that right now, but it's probably not safe for work. So yeah, anyway, back on topic. So that's a good question, and this is where the lines start to get a little bit blurred as well, because I had a lot of best practices relating to there are a lot of best practices relating to monitoring and logging and what I term visibility. So basically visibility of your product, visibility of your users, and using those tools in a way that maximizes the product's value, and that can be achieved depending on the goals of the product. But I didn't quite know where to put that visibility, because it is kind of inherently a software engineering task, but it was kind of felt like more like we only do it as part of a larger process, as part of a larger procedure. So therefore I kind of shoved it into the governance bit at the bottom. So for example, in that case, you would use your monitoring stack here, and that's what that sort of best practice would surround. So if you're using your Kubernetes stack, then this is all of the, you know, the Elastic Stack, the EFK or ELK, and Prometheus and Grafana and things like that. So that would kind of fit into this visibility box at the bottom, and you would use those tools to basically make sure that your software is running, because you know, it pretty much is required, because if it's not there and you're not aware that your product is not running, then you won't have customers for long. In terms of like the software engineering, I've kind of got this big software engineering banner here. There are a lot of fundamental software engineering. Well, you know, it's an entire discipline. It's an entire industry, and there's all sorts of best practices and things surrounding there. So I mean, I won't really go into that. I think cloud engineering is kind of emerging as a slightly different approach to achieving the same goal, and it requires a slightly different tool set. I would still, if I, like one of my employees, I would kind of still expect them to know both. I would expect them to be you know, knowledgeable about software engineering principles in terms of the you know, the good old best practices and stuff. But also, increasingly, I would expect them to be efficient and productive with cloud-based environments by default. So I think that is becoming more and more required. So insert your favorite cloud vendor here. And then and on the top level, we've got the what do we really need to build a single data science product. So I think actually I've got a slightly different slide here, and I kind of started to expand on some of this, where I picked the top layer of this data layer and kind of expanded it a little bit. So on the left-hand side, we've got raw data and models. So what do I mean by that? So in order to build a data science product, we need some raw data. We need some raw materials to start from. And once you've got that raw data, those raw materials, then we need to, you know, have a structure or a set of skills to be able to analyze and understand that data in order to solve a problem. And, you know, that's the classic data science, you know, like a CRISPR model, where we're doing, you know, figuring out what the problem is, analyzing the data, building models, evaluating that, trying to solve the problem, and then deploying it. So you kind of need all those skills just to build a basic data product. And then we've got maybe a little bit on models more specifically. Like we need to figure out what paradigm we're working in before we start. Like, is this a supervised problem? Is this a reinforcement problem? Is this a unsupervised, et cetera, because that, you know, really directs the process that you would go through and the ultimate model that you would deploy. And then we've got questions about like model architecture and how do we design it? How do we build it? Is this a simple thing? Is this a complex thing? Is it an ensemble of things? Do we need to split up the problem to make it easier to solve? Things like that. And then we've got kind of, you know, training, serving, evaluation, those kind of things. I would suggest that you need all of these things in place to release a single product. If you didn't have any of these, then you wouldn't have a product. And I would also suggest that you need everything underneath this to be able to do that. You need some software. You need some infrastructure to be able to host that. And you also need, you know, the backing of a team and a company to be able to actually build that in the first place. All right, I'll just pause there for a second.
Yeah, I just saw a question from Eduardo. If you want to jump in, Eduardo, feel free.
Yeah, so we try to deviate a bit the conversation and run tools. So what is harder? Build an ML platform capable of deploying models to production, or an ML team capable to deploy a model in production? Because we already talked about the full stack, but it's impossible to have that one person. Or what about the challenge of building that team, that dream team that's capable of get the ownership from the idea to production?
Yeah. So
If you already in any your daily or professional experience, you already try to how to build that team.
So they're kind of, they're not, you can't really compare them because it's a bit apples and orangey. So like building a platform is difficult for obvious reasons, but building a team is it's kind of a different problem. So if we tackle the first one first, building a platform is difficult because there's a lot of engineering and things that are required to get that operational. But those barriers are being lowered every day. So you know, products and services are making that process easier and easier as time goes on. So eventually you can imagine a situation where it would just be default. You know, it's not even something you really need to build anymore because it's built into everything already. On the team perspective though, that on the team front, that's a bit more difficult because like we said, the stack keeps getting bigger and bigger and bigger over time. The way companies generally solve that, especially in bigger companies, is by having teams full of people that have different expertise. And you know, that's a good strategy. But I would kind of go a little bit further than just saying expertise. It's important to have teams with different teams with more diversity, I think is what I'm trying to say. Like a particular problem at the moment is that, you know, if you're white and male and speak English, then that's pretty much the only person that you will meet when you meet data scientists and machine learning, and that kind of limits a team's vision. It limits the team's vision. So that diversity is really important, as important as the diversity in experience. But I think it is possible to find people that do sort of naturally thrive in this slightly more fuzzy knowledge world. But I mean, it comes down to specific personalities, and so the classic sort of personality split is like the difference between a jack of all trades. I'm not sure if that translates well. It's a phrase that means somebody that is quite good at a lot of things, but not really an expert in one particular thing. So I would consider myself as a bit of a jack of all trades. Because I enjoy jumping around and learning about different new things. So new ideas and new things are interesting to me. They're not something I worry about. Whereas other people are much more interested in the detail and you know, focusing on a specific subject, and they become a true expert in that very specific niche. And I think there's room for both of those types of people, but they're kind of suited towards slightly different things. So somebody that's very detailed is probably more suited to a project that is a bit more longer term and requires more focus in order to solve that problem, where a jack of all trades type person would be more suited to something that's moving very fast, an industry that's moving fast, or a product that's you know, moving fast. So yeah, does that make sense?
Yes, but for example, I can share with you my experience. One of the challenge that I have with data scientists is the first thing was to understand the kind of language they use. So in my pyramid, in the base, the first step was what they value in terms of how can I get information, because as you said before, each one have a different set of skills, specializations. Unless you're a big enterprise and you have departments for dealing with that, and that way you can throw away software above the wall. But when you're a small team, we need to go and be that jack of all trades. But considering that data science, it's a bit more complex than software and operations, for example. So one thing that I started to was, okay, let's try to understand, define the common language that works in both directions, from data science to operations in software, and from software and operations to data science. So basically, it's a bit of sharing the pain. So when something breaks in production, and when something is not, sometimes from the data scientists' perspective, sometimes they don't understand how hard it's to spin a new environment, for example, what that means. So that is the base of we are trying to build. It's the common dictionary that everyone understands, what that means, or for that terms. So that's how. First, we are trying to build the communication pipeline from the three. Basically, it's that, because the team, it's really hard. It takes a lot. When I say platform, I want to mean that writing the technical or the tools that it's needed to put in production. So the common here is how hard it's to take in the technical side and put something in production, or building the team to do that and put that model in production. From my experience, of course, building a team is always more challenging and harder, because it's very very sensible thing in any kind of organization, big, small, because in small and bigs, the one thing that always changes is teams and organization. Even if they have old technology. I used to work in the bank, and the teams changed so fast that it was incredible. So. And sometimes it's not the technology; it's more how the team changes.
Yeah, I totally agree, and I think trying to divert into a talk about management and how to build teams and how to manage teams is slightly off topic, but to try and keep it on topic, I think the classic DevOps answer is multifaceted teams, so teams with different experiences. And if you can get a good team of people that work well together, i.e. people that respect each other and get along with each other, then over time, just through osmosis, people start to pick up and learn from the other people. So the data scientists learn from the software engineers learn from the data scientists, and that team becomes more and more productive over time. But I totally agree. It's not an easy thing, and it's a clear problem for especially larger companies.
Can I say something on this?
Yeah, of course.
I'm interested in this topic. So again, from a classic DevOps perspective, one thing we missed there is that each organization has its own unique challenges. So there is no template that applies. And the way that you achieve that is by creating a great culture that facilitates continuous improvement, that facilitates experimentation and understanding what works and what doesn't, towards goals like cross-functional teams, if that's what you need in your organization. And a lot of us understand the value of cross-functional teams. At a larger scale, there might be much less cross-functional, more huge operations, who knows. But that DevOps perspective of continuous improvement and the culture part there, I think, is key. You spoke about diversity, and in different organizations, these localized things that we do may be all part of it. Our company, we have a very strong culture around diversity, so we don't have that issue of every data scientist being a white male. But then we have other challenges. We have very strong software engineering culture and a data science culture, and to bridge that historic classical software engineering is not necessarily geared towards data science as it's going to be over the next couple of years. And we always need to keep looking to change what the environment. That's changing really rapidly as well. And the notion of what good is to a developer, to a software engineer. In your table, you had cloud engineering and software engineering as different things. Yeah, but at some level, they are the same. But I understand what you're saying there. To a software engineer, he deeply cares about things like solid principles and things like that. But then to say to them, be a little bit crappier and move fast in the cloud is a difficult conversation because they're not the values they carry. So there's lots of, in each organization, there's lots of diverse issues, but come back to the DevOps principles of continuous improvement. And what you're doing today, the things you do might not be the things you need in 6 months' time, I think.
Yep, totally agree with all that. Yep.
Great. So I've got a few more questions about how you specifically implemented this idea of optimal, your optimal data science, right? And how you've gone in. Can you share a story of going into a company? I know you don't have to mention any names or mention which tools you used if you don't want to, but I'd love to hear just how you went into a company and you were able to create an optimal functioning data science or MLOps pipeline, models in production, anything that you can share around that.
Yeah, I'll try. So let's just go back to that slide again then. So this is back to the sort of the top layer of that, and where we're sort of really talking about like an end-to-end example. And I mean, the example isn't particularly exciting. I mean, the example that I've got is, going into one of these big businesses and helping them do all of this. And that is the example. But I mean, we can talk a little bit about the tooling and things that we used in order to do that. So, these steps on the left-hand side are very local to a developer. A single developer would do this, by themselves, or maybe in a small team. It's not something that you need that much scale for. Depending on, so some companies that I've worked with have had very strict IT policies, especially after all of the ransomware attacks that happened a year or two ago, where they're not allowed to install any software on their laptops. So developers, data scientists, anybody, not allowed to install anything on your laptops. So that forced them to move to hosted services a lot more quickly than they maybe would have done if they hadn't have implemented that policy. Where was I going with this? Yeah. So I was trying to suggest that the left-hand side, the gray box, can be done locally, but even in some companies that can't be done locally anymore. You need to have a service to do that. Once you start going to the valuable parts or the optimal parts, though, this is really this. You only sort of get into this when you start trying to scale. When you have multiple or many products. So the companies, some of the larger companies that I work with, we're talking in terms of hundreds of projects, hundreds of data related projects here. And so you can imagine that when they all get deployed to typically the same environment, the same production environment at least, then it is a bit of a management headache. So you do need a good set of best practices in there for auditability and reliability. So we're talking a lot of pipelines here. So a lot of build pipelines, a lot of tooling around testing and automating the validity of the things that are going into production. And there's lots we can talk about in that particular minefield. But there's also working with data as well. So actually streaming or accepting or parsing the data from wherever the source is and moving it through pipelines into a place where it's actually used that's actually a really difficult architectural task, because it's very likely that this data lives in different places. So we've had to build a lot of customizable and flexible what I call pipelines to kind of move all of that data around and put it in the right place. Provenance is it's a bit of a fancy word, actually. I'm not a huge fan of the word because it's a bit sort of confusing, but provenance is the idea that where the origin of the thing that is running in production, and that's the origin of the software, the origin of the data, the origin of the model that's being trained, and all these things. So you can go back to a very specific point in time when things go wrong, and they do go wrong. And when they do go wrong, we can ask the question, okay, why did that particular observation get a completely wrong prediction when it clearly should be good? You can go back and look at the data at a very specific point in time, look at the code at a very specific point in time, all that good stuff. And in order to do that, you need to make sure that you're, packaging the artifact that's being deployed into production well, which relies on having all of the pipelines in place to be able to build it properly. Repeatability is kind of, very similar, really. I think that the thing at the end there, the CI/CD for ML, that's another thing that's really, really missing at the moment. There isn't much standardization, and there's a big gap there for doing CI/CD, but for ML, for models, and for data as well. Because the vast majority of projects I come across do not validate their data. They do not validate the data as it's being used within the system. So they get failures all the time, but they're kind of accepted as normal because they're like, oh, well, that's normal because they've just passed there's some missing data there. There's an NEN in that data, so obviously it fails. Well, it shouldn't fail. It shouldn't, we should have something in there to validate the data before it hits your system. And again, it's very much a software engineering task, but it's important for data science. And when I get to the far right-hand side, automation, there's obviously lots you can automate, but there's a big focus at the moment on how you can re-trigger and retrain your models automatically. So some, but not all, applications are very lucky to have a natural feedback mechanism. If you're lucky enough to have the situation where your users are actually providing you with feedback, either in the form of new data or in the form of, yes, that was a good result. Yes, that was a good prediction, something like that. You can use that information to retrain your models and improve them over time. And you can then automate that process to make sure that these new models are at least as good as the old models. And once you've got that feedback cycle in place, then you kind of don't need to touch it anymore until you need to make some large architectural changes to your model. So I think that, that is certainly optimal, but it's not the place where most companies are at the moment. Most companies are still, either retraining manually or sort of retraining based upon a cron schedule, like once a day or something. And that actually works okay. I haven't come across a specific example where it's obvious that doing this continuously is really valuable, but I'm sure it is. So for the people like the Amazons of the world or the Googles of the world that are working with algorithms that are used at such a scale, I could well believe that these are really important. But for a smaller company, yeah. Sorry, go on.
You describe as not doing it.
Yeah.
Why they're not doing it? It's not the lack of availability of tools, or the why are they not doing it?
It comes down to a value. It comes down like how valuable is it? Like if we don't retrain that model so imagine just a simple cron schedule. If we don't retrain that model every day, then what's going to happen? Like nothing. We're going to lose a little bit of performance. We might lose a tiny bit on the some whatever metric you're measuring to kind of measure these things. But at the end of the day, we've got bigger problems elsewhere that are far more important than doing that.
But then also in those cases, and I totally agree with you, just to do that by, because somehow it's a best practice, actually it might not be delivering that much value.
Yeah, exactly.
Okay.
Yeah.
But there might equally be cases where there's loads of value and it remains unidentified. And even if some person believes it, can he articulate that to the organisation surrounding us? Something like that.
Yeah, totally agree. Yeah, so I think it's kind of, so I mean, that's not, so let me try and give a specific example then. So, so like I said, most of the work we do is Kubernetes based for the larger companies. The data scientist will come in, He will use a hosted Jupyter notebook probably to be able to do his data analysis. He'll get access to his data and eventually decide upon a model. Once he's decided on a model, then he would use a connection to, you know, something like Kubeflow or something like that to actually kick off a training run given a set of code that he's produced or she's produced. And the end result of that will be a pickled model usually. That'll get stuffed into an artifact registry. One of the ones we use quite commonly is something called MLflow. MLflow is a tool that is has the capability of storing versioned model parameters, and then that is then served by a set of tooling that reads from the model repository, spins up a container as and when it's needed, and then serves the user. And then over time, that model gets used. And then later down the process of when the person is kind of interacting with that model and providing their feedback, that feedback gets you know, saved into I mean, there's various words for it at the moment, but they call it like a continuous learning pipeline. Effectively, you're storing the responses somewhere in a database or in a bucket or whatever, and at some point in time, it will the continuous learning pipeline will be triggered, and it uses that new information to go back to Kubeflow, retrain a new model, deploy it back to MLflow, and then the new version gets deployed, and then you have like the A/B testing style stuff in there to verify that you've not broken anything. So there's several kind of loops and feedback cycles going on, so it gets a little bit complicated at times.
That's great. That's perfect. Thank you for that. Looks like we have hit the hour mark. I want to make a few short announcements and then we'll wrap it up. Can we send these slides to everyone? Phil,
Yeah, sure.
Is that all right? Great.
Yeah, no worries.
Cool. So we'll send you all these slides, and we'll also send the recording of this where you can find it on YouTube. We also are going to put in the Slack a poll for our office hours, because we're going to start doing office hours every other week. And the office hours idea is just we're going to come together quite like this and talk about how we're getting on with our MLOps projects, and if we're hitting any walls or anything. Hopefully somebody in the community can help with that. And it's a way to use our combined knowledge, sorry. And so yeah, the Slack, the link, we're going to put that in the chat again just before, but if you go to MLOps.community, you will find a link to the Slack and you can join us, introduce yourself, and that is about it. Is there anything else you wanted to add, Phil? Thank you so much for this. It's been great.
No worries. Thanks a lot. Thanks for everyone for listening, and hope you all managed to get through this cabin fever safely.
Yeah, perfect. Have a great night, everyone. We'll see you later.
Thanks. Bye-bye.
Bye.